When it comes to living healthier longer, we need to address inflammatory foods. These are foods that we eat in large quantities, and I've identified 3 that make it to the top of my list of inflammatory foods that also contribute, obviously, to oxidative stress. And I want to flag them for you, and I say flag because flag is an acronym that actually stands for these 3 things. They are fructose, linoleic acid, and gluten. And you might be surprised that these are the ones that I'm labeling or picking on. Fructose is a sugar, so we've dug down beneath the sugar is a problem to the real problem, fructose. Linoleic acid is in fact the omega-6 fatty acid in seed oils that is of concern. And then gluten, we're familiar with that in baked goods as well. So fructose, linoleic acid, and gluten, flag those 3. They are inflammatory foods. Now, we're going to talk first about fructose. It's a sugar. It's one of 6 dietary sugars. And those 6 dietary sugars consist of 3 monosaccharides and 3 disaccharides. The disaccharides are made up of the monosaccharides. You'll be familiar with most of these. The disaccharides are sucrose, lactose, and maltose. And they're made up of, in the case of sucrose, is made up of fructose and glucose. Lactose is glucose and galactose. And maltose is 2 glucose stuck together. We're going to talk about them from a dietary standpoint, strictly on the basis of the monosaccharides, because in reality, as soon as we ingest the disaccharides, they're effectively cleaved into the monosaccharides. So when we take each sugar, we're basically getting 50-50 fructose and glucose. And so we'll look at these things. From a point of view of metabolism, glucose is a sugar that is at the heart of how our bodies work. Without glucose, we don't exist. Our entire energy production and storage system is built around glucose. It is the simplest structured carbohydrate. Most carbohydrates, especially simple starches, are also immediately converted into mostly the monosaccharides. And so in the case of glucose and galactose is also metabolized into glucose. It all feeds into our energy production and storage system, critical for us to function and exist. Now, in the case of fructose, it's different. It's a 5-membered ring sugar and not 6, which is what glucose and galactose are. And it doesn't enter into the body and have anything to do with the energy production and storage system. Fructose is a sugar that is initially metabolized in the small intestine. That's consistent with our evolution as hunter-gatherers, eating fruits, etc., which is primary source of fructose in nature. And we metabolize it there. It gets converted into oligosaccharides, and some of those end up being converted into energy later on in the processes. But for the most part, it has nothing to do with what happens with glucose, the primary sugar that we run on. And the oligosaccharides that are produced in the metabolism of fructose initially in the small intestine tend to be inflammatory in nature. They tend to perhaps get deposited in the tissues and lining of the intestine, and there they are inflammatory in nature. If we end up with too much fructose, and that happens quite a lot in the North American diet especially, then fructose is transported into the bloodstream where it goes to the liver and it is metabolized in the liver. That metabolism also produces oligosaccharides that have a tendency to get deposited into the tissue and lining of the liver, and likely is a significant contributor to liver conditions like non-alcoholic fatty liver disease. And I think also the inflammatory nature of the oligosaccharides in the intestine are probably significant contributors to the vast array of intestinal diseases we have today, IBS, Crohn's, etc. So the picture is that fructose is actually quite different. It's metabolized in a different manner. It produces inflammatory metabolites, and none of these are particularly helpful if we're looking to live healthier longer.